Hi guys, sorry I'm not there today, but I'm just gonna make this video for you guys and everything should be good. Okay, so we are moving on to 2.2, which is now gonna be slope and perpendicular lines. Okay, so on Tuesday we talked about slope with parallel lines, so we knew from that whole thing that parallel lines have the same slopes. So now we're gonna kind of look at how the slope of perpendicular lines relate. Okay, so I'm not going to go through all of this text. I'm going to pull out the important pieces for you so we can kind of make this a little bit more simpler. So the first theorem, which I have starred for you, says that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay, so if I say the word product, I hope that you are thinking, oh, I multiply. Okay, so if I multiply two slopes together, then they will equal -1, and that will tell me that they are perpendicular lines. Okay, so this first part of this book goes through and kind of takes this generic setting and proves the whole idea that, yes, in fact, if you multiply two perpendicular slopes, they do equal -1. So that's this kind of piece right here. Hopefully, I'm just going to kind of go straight past that and just hopefully you realize that if you multiply two slopes together and get -1, you know they're parallel. Okay, so we're going to go into the next set here and say using slopes to classify right angles. Okay, so perpendicular means a 90-degree angle, so therefore it's perpendicular, or a right angle. Okay, so this takes us through the proof of proving something is a rectangle. Okay, so by definition, what are things that are true about a rectangle? Okay, rectangle by definition has 4 90-degree angles. So all 4 of these are 90 degrees. Also, opposite sides are congruent. Okay, so this side would be congruent to that side. This one would be congruent to that side. Also being true, because of those facts, a rectangle is in fact a parallelogram. Okay, so that means the opposite sides are parallel as well. Okay, so things to remember about rectangle. Opposite sides are parallel. Okay, and all 4 angles are 90 degrees. Okay, and that's the biggest part of this lesson that we're going to be looking at. I also did say that the opposite sides are congruent as well. So we can say also opposite sides are congruent. Okay, but these are the pieces that we're looking at, particularly that and that, the slopes. All right, so we are going to, or they are going to take you through, and they're going to prove that this is in fact a rectangle given 4 points. Okay, so I'm not going to go through this whole example for you. I'm just going to kind of run through the quick details of it. They initially find the slope from A to B to be 1/2, the slope from C to D to be 1/2. So these two are the same. So opposite sides are parallel. Okay, BC and AD are also parallel. Okay, so that's proving that first thing, opposite sides are parallel. Okay, and now once we get to that point, step 2 is going to be proving that they're perpendicular to each other. So they're going to say the slope of AB times BC, and you multiply 1/2 times -2. If you get -1, then those two lines are perpendicular. Okay, and it goes through all 4 angles and proves that all 4 angles are in fact perpendicular. Okay, so those are the steps that you're going to need in order to prove that a shape is a rectangle. Okay, so for B, this is now going to be us doing this, so this is something you might want to consider writing down. Okay, we're going to take this particular trapezoid, and it has 2 right triangles. Okay, so first it gives us J is negative 3, 3, which is shown. K is 3, 1. L is 2, negative 2. M is negative 1, negative 1. Okay, so next thing I want to do to decide if these are parallel or perpendicular, we want to find the slopes of each of the lines. We're going to find their slopes. So from J to K, they did this algebraically and found the slope to be negative 1/3. So from K to L, so we're looking from K to L, we're going to go negative 2 minus 1, so we're using the L, and the X is positive 2 minus 3. Okay, so if you subtract that, that gives you negative 3. On the bottom, you get negative 1, and that would give us a total of 3. Okay, slope of that one is 3. For LM, L to M, so we're going to go M minus the L. So Y, 2, so negative 1 minus negative 2. On the bottom, we're going to do the difference of x's, so negative 1 minus 2. So on the top, I have negative 1 plus 2.
Savannah Washburn, please come to the office. Savannah Washburn, please come to the office.
On the bottom, I have negative 3. So this one again, negative 1/3. So hopefully at this point you go, J and K and L and M are parallel because they're the same. Okay, M to J. So I'm going to go J. Oh no, they start with J. So 3 minus negative 1, and then negative 3 minus negative 1 for the M. So on the top I have 3 minus negative 1, which is 3 plus 1, 4. And on the bottom, negative 3 plus negative 1, or plus 1 is negative 2. So that one gives me a slope of negative 2. Okay, so just from these slopes, all I needed to show that we had a trapezoid is that we have one set of parallel lines. Okay, so we have that. So the next thing that we need to prove is that we have two right angles existing. So that's two perpendicular lines. So I'm going to be looking at this picture and going, okay, the ones that look right to me is this angle here. So between ML and KL, and also looks here. So between KL and JK. All right, so since the slope of JK is negative 1/3, JK is parallel to LM. Since the slope of JK, which is 1/3 times the slope of KL, so if you look at KL, that's 3. And if you multiply 1/3 times so 1/3 times 3, I'm not sure if you guys noticed a typo here. Look at that. That should be a negative 1/3, right? We just pulled it straight out. So negative 1/3 times 3 is negative 1. Oh my gosh, I can't believe I made that mistake. Okay, so that's going to show us that the slope of KL, which we said was 3, and the slope of LM, let's go back and look at LM, is negative 1/3. Negative 1/3. So 3 times negative 1/3 is negative 3/3, so negative 1. So now that is also perpendicular. So JK is perpendicular to KL. And KL, LM. Boom, two perpendicular angles. So therefore we can say that our trapezoid is in fact a trapezoid with two parallel lines because or JK and M. JK and LM are parallel, and we kind of said it already. JK is perpendicular to L or KL, and KL is perpendicular to LM. All right, so nice. We proved that particular example. Okay, they do reflect on this and say, why is it a parallelogram? Okay, and hopefully you're saying, no, it is not a parallelogram, because parallelogram would have two parallel sets of parallel lines, and since these two are not parallel, it's not a parallelogram. Okay, so you can say KL and MJ are not parallel. KL and MJ are not parallel. So only one side is, or one set is parallel. Okay. So question number 5, they are asking us to show that this here is a rectangle. Okay, so we are going to prove that it has opposite sides that are parallel and also 4 angles that are right angles. So let's start with D to E. Okay, so actually maybe before I do this, let's go ahead and give all of these points. So let's say D is -2, 3. Point E would be 4, -1. F is 2, -4, and G is -4, 0. Okay, so we're going to find the slope from D to E. So let's go, D is 3 to E, so Y is -1. The X would be -2 minus 4. So 3 plus 1 is 4, and -2 minus 4 is -6, so that would reduce to -2/3. I'm going to go opposite, because I like to do the pairs, I think. So G, F would be the ones that would be parallel. So if I go G to F, it would go 0 minus -4, and -4 minus 2. So 0 minus -4 is 4, and -4 minus 2 is -6, and bam, -4, 6 reduces to -2/3. So parallel. Okay, let's go to the other sides. So G to D, let's go from G to D. So we're going to go 0 minus 3, and then -4 minus -2,